Hello guys, this is Prime Concept. I'm here once again to unravel the concept under optics. So in this video and beyond, we'll be considering optics, opening up the topics in optics one after the other, right? If you have been following my videos, I would encourage you to do well and subscribe to my channel so that you can constantly be updated, like my videos, comment, and always share with your friends so that they can benefit from this also. Thank you. Now I want to look at optics, and the part we want to start with is reflection of light at plane surfaces. Now, first of all, we need to understand what optics actually means. Now, optics is a branch of physics that studies light and its propagation. That is optics. It's a branch of physics that studies light and studies the propagation of light. When we say propagation of light, we simply mean how light travels. We know that light travels naturally, yes, on a straight line. So optics is that branch that analyzes light and how it travels from a source. So that is optics. Now, in the study of optics, optics is divided into two major parts. We have two types of optics. Number one type of optics we have is geometrical optics, which will be the focus of our study. And then the second part of optics we have is physical optics, which would later come. Now, what is the difference between these two areas of optics? Geometrical optics is also known as ray optics. So one branch of this is geometrical. Geometrical, also known as ray optics. So this is one type of optics we have. Then the other type we have is physical optics. So these are the two branches of optics that we have. Now this is where we'll focus on, but I'll give a hint on both of them. Geometrical optics is a branch of optics that studies light using light rays. So geometrical optics uses rays. Rays are actually straight lines. So geometrical optics uses ray to study optics. Now whenever you hear the word geometry, of course, it tells you that a little of angle calculations will be involved, right? So that is geometrical optics, the study of optics using rays or lines. Then the other part of optics is what we know as physical optics. Physical optics is a branch of optics that considers light as a wave that emanates from a source, right? And then is advancing towards another point. So that is physical optics. So in other words, while geometrical optics studies light with rays or consider light as rays, physical optics considers light as wave. So this is where we'll be talking about de Broglie's wavelength in form of light. So this is where we'll be talking about interference of light and others, right? So let's go back to the one we want to study for today. So like I mentioned, we want to consider geometrical optics, right? Geometrical optics. And then using it to analyze the reflection of light at plane surfaces. So what is ray? Remember we said geometrical optics uses ray. So what are rays? Rays are straight lines. They are lines that are drawn from an object. Those are rays. They are imaginary lines that are drawn from an object, indicating the path of travel of light. So they are straight lines drawn from an object that indicates the path that light travels through, the path of travel of light. So that is what rays would always tell us, to tell you that the light from this object is traveling along this path or traveling along this path. So those are rays, right? Now whenever we want to locate an object at a certain point, or want to locate an image that is formed by an object, we would need to always use rays, right? We don't use just one. We need to use two or more rays. So when you have a collection of rays, say you have 2, 3 or more rays, a collection of rays is no longer called rays. In physics, we have another name for that. So a collection of rays in physics is known as beam. So we say a beam of light. So if I have this as one ray, I have this as another ray, I have this. Then we can call this group of rays a beam of light. So that is what a collection of rays actually represent, because that is what we'll be using most of the times. So if we consider a beam, we can have three main types of beams. So there are three types of beam. So there are three types of beam. Number one type of beam we have is what we know as parallel beam, or you can say parallel rays. So that is number one. So what are parallel rays? They are lines, they are straight lines that don't touch each other, right? They are straight lines that don't meet. They are parallel to each other, advancing from a source. So this is what we mean. So this is why we always use an arrow to indicate the direction of travel. So this means that this ray is traveling forward. So we have this. Don't mind my drawing, it's not drawn to scale because I'm using freehand. So you can see this. So these three lines are considered to be parallel beam, right? Because it is considered to travel straight. They won't meet at any point. So they are parallel beam. Then number two type of beam we can have is what we call convergent beam. Convergent. So convergent beam are rays that would meet at a point. They are rays that travel and will meet at a point. They would converge at a point. So this is what we mean. Convergent beam. So this is what we mean. So if you continue, you will notice that they will meet at a point, right? So this is what we call convergent beam, rays that meet at a focus, at a point. So the point where convergent beam actually meet or tend to meet is what we know as our focal point. We'll still learn that later. So this is the focal point. So that is where convergent beam actually meets at a point, at a central point, which we call, under optics, we call it focal point. And then number three is what we call divergent beam. Divergent beam. So these are the three types of beam that we have. Divergent, right? Now, divergent beam are beams that spread from a point. They are beam or rays that spread. Starting from a point, they spread outward. That is what we call divergent. Say this is a point we have, and then you have rays coming out from this. So they will tend to spread like this. The arrow simply indicates the difference between these two things. You will notice the arrow in this case is pointing to this point, but the arrow in this case is moving out of this point. So this is a divergent beam. They spread out from a point. This point, of course, is still known as your what? Your focal point. So these are the three types of beam that we have, right? The parallel beam, the convergent beam, and then the divergent beam. So those are the three types of beam that we have. Now, we want to look at how this beam or this ray of light, rays, would reflect on a plane surface, right? Now, what is reflection? If I bring light, say a torchlight, and I flash on this my board, you'll notice that there will be reflection, right? If you're looking at the board and you're looking at the point where I'm flashing that light, it will somehow disturb your eyes. The reason it will disturb you, I'm not directly flashing that light to your eyes. I'm flashing it to the board. But when you look at the board, the part where that light is shining on, it will disturb your eyes simply because when the rays from that light hits the board, it will bounce back and then enter your eyes. That is why you observe that disturbance in your eyes. Now, whenever you have light and you flash light on any plane or smooth surface, there are three things that are possibly going to happen to that light. which are going to form the basis for this course. But in this part, we're going to consider one, right? Now, what are the three possible things that can happen to light when you incident it or when you flash it on a surface? The three things that can happen to light that are incident on a surface. Number one is reflection. So when you flash light on a plain surface or in a smooth surface, depending on the type of surface, one thing that would happen to it is reflection, which is what we want to consider first. Now, what is reflection of light? Reflection is simply the bouncing back of rays to the same medium from which it is incident. That is reflection. The bouncing back of light to the same medium from which it was what? Incident. Now, you can see this very simple scenario if you have your television at home and you have your remote control. Now, when you check the remote of your television, you will see something that looks like a bulb in that your remote control. That thing that looks like a bulb, some of them, when you press the remote, you won't see light there. Some of them you would see light. Now, that bulb you see there is an infrared light. That bulb radiates or releases light, but the kind of light it releases is infrared, right? Now, if this board is my television and then I bring that remote, I want to control my television. I decided I won't point it directly to my television. I point it to the wall opposite my television. Go and try this. You will notice that when you control that remote pointing to the wall opposite your television, it will still control your television. So why does it happen like that? Very simple. The reason is because when you flash that remote on the wall facing your television, the rays emanating from that remote would hit the wall and bounce back and connect to the receiver of your television and then control it. So that is a simple scenario of what? Reflection. So what is reflection? The bouncing back of light ray from the medium to the medium from which it was what? Incident. So that is one thing that would happen to light when you incident it on a surface. Number two, another thing that would happen to light when you incident is refraction. Refraction, take note, reflection and refraction are not the same. So it's refraction, right? So that is one thing that can happen to light. So what do you mean by refraction? Refraction is simply the bending of light ray as it crosses the boundary between two different media. That is refraction. We'll study this in a later part of this course. So that is refraction, right? Or you can still call this transmission. So if you don't call it refraction, you can say transmission. So when you incident light on a surface, of course, before you have refraction, it means that the light has been transmitted through that surface to another part of it. So that's why we can say transmission. It is not because they're exactly the same terms, right? Now, number three thing that can happen to light that is incident on a surface is what you call absorption. Absorption. So this is the number three thing that can happen to the light incident on a surface. Absorption. And this is what we're going to study under thermal physics. Absorption of light, right? Yes. So when you flash light on a certain surface, of course, in some surfaces you would expect reflection. Most surfaces, all surfaces would reflect a percentage of that light, right? Yes. And then some part of that light would also be absorbed. And there are some surfaces that when you flash, a good part of that light would be absorbed by that surface. You won't see it back and you won't see it coming out from the other side of it, right? So these are three things that would happen to light whenever you incident them on a surface. Now remember, we're trying to introduce the concept of reflection of light at plane surfaces. Now, since we have learned the idea of reflection of light, we mentioned that reflection is the bouncing back of light to the same medium from which it was incident. That is reflection of light, right? So generally we have two types of reflection. So there are two types of reflection we should know as physics students that are studying STEM courses, right? Yes, so there are two types of reflections that we should know. Number one type of reflection is what we call regular reflection. Number one is what? Regular reflection. Now, regular reflection is a kind of reflection that occurs when parallel beam is incident on a smooth surface. Regular reflection occurs when parallel beam is what? Incident on a smooth surface. And if that surface is smooth, when you incident parallel beam on that surface, the reflected beam would also be parallel. Then you say that regular reflection has occurred. And this is what we mean by regular reflection. So if I have this is a smooth surface, we don't have a perfectly smooth surface. We'll say this is a smooth surface. Now if I incident light like this, parallel beam, so these are parallel beam incident on this surface, then I would expect this to come out in this way, parallel to each other. So you see that the reflected beam is also parallel. So this is what you call your regular reflection, right? Then number two type of reflection we have is what we call diffuse reflection. So number two is diffuse reflection. Of course, you know what it would be, right? Yes. Diffuse reflection occurs on rough surfaces. It happens when light is incident on rough surfaces. So what makes it diffuse reflection? What makes it diffuse is that when you incident parallel beam on a rough surface, the reflected beam interfere with each other. They are no longer parallel. The reflected beam is no longer parallel. They don't come out parallel to each other, so they can intersect each other. So this is what we mean by that. So this is a rough surface, and then we have parallel beam incident. We have parallel beam like this, incident. So what makes it diffuse is that when they are reflected, they are no longer parallel to each other, even though the incident will be parallel, but the reflected is no longer parallel. So you have something like this. You have something like this. You can see that this reflected beam is no longer parallel. So that is why we call this a diffuse what? Reflection. So I believe this is very clear. Please take note of what we are explaining sequentially, right? Now, since we have looked at what reflection is, and we have also learned the types of reflection we have, we want to at this point consider the laws of reflection. There are laws that govern reflection of light on a surface. So we want to look at the laws of reflection. Laws of reflection. So we have two laws of reflection. So number one law of reflection simply says that the incident angle, when light is incident on a surface, the angle of incident equals the angle of reflection. That is the first law of reflection, that the incident angle would always be equal to the what? Reflected angle. So what do we mean by incident angle, and what do we mean by reflected angle? I would simply illustrate that. I would say this is a plane surface, and then I draw, before you draw incident or reflected, the first thing you would always need to show is your normal. A normal is a line that meets your plane surface at an angle of 90 degrees. So that is why we call it normal. Of course, that normal is a line that actually obeys the law of reflection. So that's why we call it normal. It obeys the law of reflection. But that is, so this line is our normal. So any other ray you draw from here, you can now describe what that ray would be. So if I draw a line like this, hitting this point, and then I put my direction like this line that is entering and hitting at the normal, this line is what we call incident ray. The ray that is pointed towards a point. So this is your incident ray. Incident ray. Now the angle the angle that the incident ray makes with the normal, we call that angle of incidence. Now, when you incident light on a plane surface, right, that light will be reflected. An amount of that light will be reflected to the same surface. This top and top part is the same surface. So you will have a part of that light reflected in this form. So according to the first law of reflection, it's saying that this angle you have here, which is I, is equal to this angle, which we call capital R. Now, what does this capital R signify? Capital R signifies our angle of reflection. So what is the first law saying? The first law is simply saying that I, which is angle of incidence, equal to R. That is what the first law of reflection is saying. So R is angle of reflection. So R is angle of reflection, and then I is angle of incidence. So this is the first law. Now, but we want to point out some other things here before we go to the second law of reflection. Now, what are the things we want to point out? We have another angle here. So I'm going to call this angle theta, right? Now, what is theta? Theta is the angle between your incident ray and the surface. Theta is the angle between your incident ray and the what? Surface. So what do we call theta? Theta is actually known as glancing angle, angle of glance, or you can say glancing angle. So theta is glancing angle. Theta is what? Glancing angle. So what is your glancing angle? Your glancing angle is the angle between your incident ray and your surface. That is your glancing angle. Then another angle that is very important to us to note is this. Now, if I decide to continue this incident ray, if it travels to this second medium, the direction it's supposed to take is supposed to travel straight like this, assuming everything should go, this is same medium, it should go straight like this. If this medium and this medium are same, when this enters here, it will still travel straight. But then because of reflection, you now notice that a good part of it is now coming back to the same surface, right? So there is an angle between the path that light is supposed to travel and the reflected ray. So this angle is what we know as D. Okay, is what we know as D, right? So what does D represent? D is called the angle of deviation. So D is angle of deviation. So what is angle of deviation? The angle between the reflected ray and the path light is supposed to travel through. That is angle of deviation. So I believe these angles are very clear to you. Now, to know that you really understand this, I will give a problem. Then you produce the answer before checking my own answer. So I have this. The question says, find the angle of reflection and deviation. To find the angle of reflection in this diagram and then the angle of deviation from the diagram, right? Now, quickly, just pause the video and try to solve this, then come back and check if your answer is correct. Now, I want to find the angle of reflection, now, which is actually this angle, right? Now, the first thing you want to remember is that this whole angle, like this, which I'm mapping out, this whole place is actually an angle of what? 90 degrees. The angle between your normal and your plane surface is 90 degrees. So what it means is that your theta, what did we call theta again? You are very correct. Theta is angle of glance. So theta plus I. What did we call I? Angle of incidence. So theta plus I must always, in this case, be 90 degrees. Would always be 90. So if I have that my theta in this case is 30, so I'll simply have 30 plus I equals 90 degrees, right? So I'm trying to find I. So what is I going to be? Going to be 90 degrees minus 30 degrees. And my I is going to be what now? 60 degrees, right? But is this what we're looking for? Of course not. The question says we should find the angle of reflection, but we've just gotten the angle of incidence. Of course, you are very correct. That is very close to what we are looking for, right? Yes. You recall the law, the first law of reflection. What does it say? The first law of reflection simply says that the angle of incidence is always going to be equal to the angle of what? Reflection, when light is incident on a plane surface. So what it means is that our angle of reflection, R, automatically becomes what? 60 degrees. That is the law of reflection. I believe that is very clear. And the next part of the question says we should find the angle of deviation. So what is the angle of deviation? The angle of deviation is actually going to be this angle, right? Yes. So how do we find it? Very simple. So now we want to find D. Of course, we know that everything from here, follow this very carefully. You know that everything like this is a straight line, right? This is a straight line. So you know that everything like this should add up to what? You are very right, 180 degrees. So let's do that addition very quickly. So we're going to have I, which is this first part of the angle, plus what now? R, which is the second part of the angle, plus what now? D, which is the last part of the angle, should be equal to what? 180 degrees, right? Yes. Now, what do we know I to be? We know I to be 60. We also know R to be 60, then plus D equals 180, right? So 60 plus 60 is 120, plus D equals 180 degrees. So since I'm trying to find D, what is D going to be? D is going to be 180 minus 120 degrees. So my D automatically becomes what? 60 degrees. So my angle of deviation in this case is what? 60 degrees. So I believe this is very clear to you, right? Now let's advance. Let's move on. Remember, we're considering the laws of reflection. We've mentioned one law of reflection, right? The second law of reflection, number 2, the second law of reflection simply says that the incident ray, the reflected ray, and the normal at the point of incidence all lie on the same plane. The incident ray, the reflected ray, and the normal at the point of incidence, they lie on the same surface, on the same plane. So that is what that law is saying. It's simply telling you that, I don't know, I would have gotten something to really explain it. Let me see. So what this thing is, if this second law is telling us, this is a surface or this is a plane. So it's telling us that if this is our incident ray and is lying on this surface, right? It's also telling you that your reflected ray must be on this same surface. Your reflected ray will not come and be at this surface. This is another surface. This is another surface. But the law is saying that everything will be happening on this surface. Not that your incident is here and then your reflected will now come to this place. That is what that law is saying. Your incident ray, your reflected ray, and your normal at that point of their incident all lie on the same surface, on the same plane. That is what the law is telling us. So take note of it, write it down so I don't waste your time here. So I believe these things are very clear. Now the next part we want to consider, since we have learned what optics is, we've learned geometrical optics, which is what we are dealing with. We've also learned what a beam is. We've learned the kinds of beam we can have. We've learned reflection, the types of reflection. We've learned the laws of reflection. So the next thing we want to look at is reflection at a plane surface, right? That is reflection of a plane mirror. reflection on a plane mirror. Everybody knows what a mirror is, right? Every student in Nigeria, in the US, in the UK, everybody knows what a mirror is, and then you know what a plane mirror is, because virtually every day we use plane mirror, notwithstanding the fact that the internet era is actually trying to fizzle out mirror, because most people view themselves from their phone. They don't have to check the mirror again to know how they look, right? Or not that notwithstanding, you still know what a plane mirror is, right? Yes. A plane mirror is simply a plain glass in which one part of it is coated. That is a plane mirror. A plain glass, just like what we use for our windows, right? So a plane mirror is a plain glass with one part of it coated. That is what we call a plane mirror. So I believe this is very clear. Now, when you're studying physics, one of the symbols we use to denote plane mirror is a straight line telling you that it is plane, right? And then the part that is coated, we denote it with lines like this. So when you see something like this in physics, it simply means that this part that is shaded is the back of the mirror. This is the back of the mirror, and this side is what? The front of your mirror. So it means if you want to view yourself on this mirror, you're going to stand here. So anything happening at this side is happening at the back of the mirror, of course. Now, when you come to the front of the mirror and you view yourself, you notice that you're seeing yourself actually inside that mirror. So for some persons, they may say, it looks as if I'm deep inside the mirror. So you now go to the back, say, let me check if I'll still be there. Of course, you know that when you go to the back to check, you won't see anything, right? So in physics, whenever you look at yourself at a plane mirror and you see yourself deep inside the mirror, what you're actually seeing is not a real image. But then what you're seeing inside that mirror in physics, that is called what? Image. It is called what? Image. The image of yourself. You that is standing in front of that mirror, what do you represent to that mirror? Very correct. You standing in front actually represents the object of that mirror. Then that one you are seeing inside the mirror, what does it represent? Very correct. It represents the image of the object, the image of yourself, right? Yes. So for a plane mirror, we're going to learn some of the properties of the image that is formed by a plane mirror. So what are the things that are peculiar to every plane mirror? What are the images, the kind of images they form? So the first thing, before we look at their properties, we want to see how to form images on a plane mirror. And it's very simple, trust me, very simple. So we want to look at formation of image on a plane mirror. Image formation. Image formation, so that is what we want to consider now. Now, so I have a plane mirror like this. So I have a plane mirror like this. I want to form the image of an object. Now let's assume that this is our object, because I'm drawing with free hand, so you try to bear with me. So let's assume this is our object. Maybe this marker, as what I've indicated here, is our object. Why do we call it object? Because that is what is standing in front of the mirror. So we want to see this inside the mirror. So this is the object. Now, whenever you want to form the image of an object, remember we said you use what? Rays. You use what? Rays. And what are rays? Rays are straight lines that emanate from an object. Those are what we call rays, right? So I'm going to have, say, I draw a straight ray like this, right? So when I put an arrow forward, simply means that is your incident ray. Now, if this ray is straight, it means it will meet this mirror at an angle of 90. So if it hits it at an angle of 90, it will come back in same direction. So it will be reflected in same path, right? Now, if I do the same here at the bottom, draw a parallel line incident, when it hits your mirror, because it is 90, it will still be reflected at an angle of 90 in the same direction, right? I'll say, now say I want to now incident at an angle. Let's say I incident like this. This is my incident ray at an angle, right, to the mirror. And when it hits your mirror, it should come back. It should come back in a way that the angle of incident and angle of reflection should be what? Equal. Now, if I do the same thing here, say I incident like this, when it hits, it should come back again in a way at the angle of incident and angle of reflection are what? Equal. Now, if I take my reflected rays, because reflected ray simply means it is coming from somewhere. So where is this reflected ray coming from? Where is this reflected ray coming from? It's coming somewhere from behind of this mirror, the back of this mirror. So let's take it backwards and see. I'm not drawing to scale. So if I take it backward, I take this one, we still have a reflected ray here. I take it backwards. So you'd see this. If I take this reflected ray backwards, take this one backwards, right? You can see. So it means this point where all these reflected rays meet. This is where my image, this is where my image is actually formed, and this is my what? Object. So this is how we can form images on a plane mirror. So what I have here is my object, and what I have here is my what? Image. So what can you observe from this? So these are going to lead us to the properties of image formed by a plane mirror, right? So you try to draw this. We can do for so many others. I can draw this and draw again, different shape, right? We can do that. So we want to look at the properties now. So the properties of this image formed by a plane mirror. So what is one of the properties? It is very clear from this. So one of the properties is that the object height is the same or equal as the image height. So take note of that. One property you should know is that the height of the object is equal to the height of the what? Image. That is one property you should note. Another property you would see from this, even though I drew with a free hand, but it still looks it looks perfect. This distance, the distance from where this object is to my mirror, we usually call it U. And what does U stand for? Very correct. U stands for object distance. So the distance from an object to the mirror, you call it object distance. So take note of that. In same way, the distance from my mirror to my image is denoted as V. And what does V stand for? You are very correct. V stands for image distance. Image distance. Now, if you watch, you would observe second property, that for a plane mirror, object distance and image distance are what? Equal. First property, the height of the object or the size of the object and the size of the image or the height of the image are what? Equal. Second property, the object distance and the image distance are what? Equal. So that is second property. Please take note that your object distance is the distance from your object to the mirror. Your image distance is the distance from your image to the what? Mirror. Now, number 3 property you should note. Now, you will notice that your object is in front of the mirror, but then your image is somewhere at the back of this mirror, right? So whenever you form images at the back of the mirror, those images are said to be what? You are very correct, virtual. So number 3 property is that the images formed by a plane mirror are always virtual. They are always what? Virtual. So that is number 3 property you should note, right? Then what is the next property you should note? Thank you, very correct. You see that my object is standing same way, even though that I should have used a point. If I had done something like this, use a pointed image object like this, you will still notice to still form a pointed image like that, pointing up. So that gives us the 4th property, right? The the image formed by a plane mirror is erect. Is what? Erect, or you can say upright. So what do we mean by erect or upright? You can see that this object is standing and there's a pointed mouth facing up. So this pointed mouth is still facing up, right? So it means it is upright. Assuming that in this case, this pointed mouth is now facing down, you will simply say that the image is what? Inverted. But in this case, since the pointed mouth of the object is up, the pointed mouth of the image is up, then you can simply say that the image of a plane mirror is always going to be what? Erect, right? Or upright. Now, as a point to note, you should take note that every virtual image of a mirror, plane or curved, every virtual image would always be erect. Then whenever you have real images, they would always be inverted. So you take note of this point. Every virtual image would always be what? Erect. Every real image would always be what? Inverted. So you take note of this point, right? Yes. So then the last property I want to mention, which you cannot clearly see from this diagram, is that the images formed by a plane mirror are always laterally inverted. They are always laterally inverted. So the image of a plane mirror is always laterally what? Inverted. So what do we mean by lateral inversion? It's simple. If I have a symbol, say the symbol of the letter L facing my plane mirror, if I place it, when the image of this is formed on this mirror, it would form like this. To form like this. So you can see it's a lateral inversion, right? But assuming it was formed facing here, then there's no lateral inversion. But this is always how it will form. You want to test this, go to your plane mirror, place your hand this way, and you notice your hand would face you this way. So that is a lateral inversion. So these are points you should know about the properties of the images of a plane mirror. Then finally, another term we want to learn for a plane mirror is what we call lateral magnification. Lateral magnification. Lateral magnification. So it's denoted by the symbol small n, magnification. So lateral magnification is the ratio of image distance to the ratio of object distance. It is the ratio of what? Image distance to the ratio of object distance. Is ratio of image distance / height to object distance / height. So what do we mean by this? In a simple mathematical form, it means that magnification, lateral magnification for a plane mirror is V over U. What does V represent? Very correct. Image distance. What does U represent? Object distance, right? So this is magnification. Also, you can say that magnification for a plane mirror is what now? Height of image over height of object. So any of these two formulas would go. Height of image over height of what? Object. So this is the formula for the magnification of a plane mirror. And finally, what should you note about the magnification of a plane mirror? Very correct. You should know that since for a plane mirror, the object distance and image distance are always equal, it simply means that the magnification of a plane mirror is always going to be unity. The magnification of a plane mirror is always going to be unity. Unity simply means 1. So for a plane mirror, M is always going to be 1. So you take note of this. So I will stop this video here so that it doesn't become excessively long. So do well to watch this video from the start to this point. This is going to lay a foundation for the next topics and the next videos you'll be seeing, right? If you have enjoyed this video, do well to hit the subscribe button, like my videos, comment and share with your friends so that they can also benefit. In my next video, I'll be considering rotation of a plane mirror, and then from there we can move on to reflection of curved mirrors, right? Thanks for watching. Remember, this is Prime Concept. Thank you.